Get out of the way. My name is Mike Ruiz. I'm a solutions architect here at AWS. I work on the partner team. I've been here for about 3 years. I'm here with Alan Brown.
Also a solution architect on the partner team. I've been with Amazon for about 5 years now.
Right. We both have extensive experience outside of Amazon operating production infrastructures, both on Amazon and in scaled enterprises. And today we're going to talk about anti-patterns and learning through failure. So it's probably a good idea to define an anti-pattern. An anti-pattern is an operational practice that's successful in the short term or intermediate term, but are known to AWS experts to lead to faults or eventual fault in production or when challenged with some sort of event. And kind of interestingly, I work with a lot of partners talking about best practice. Where best practice comes from is largely the investigation of anti-patterns in accounts. So we're going to talk about anti-patterns, but really this is a conversation about best practice. Put another way, best practices are learned and often earned behavior. So when I have conversations with partners about best practice, I'm often challenged, where does this come from? I don't actually have that conversation when I'm working with a customer that's had a fault and we're talking about best practice. I think they're pretty convinced of the value. And so my job is to really explain the value of a particular best practice and ideally learning from the behaviors of others, learning from faulting in other people's accounts as opposed to our own. That's kind of the ideal outcome here. So that's a lot of what we do. Kind of put another way, this is the myth of best practice creation. We don't invent best practice sitting in a park under a blue sky. We both live in Seattle. Blue skies don't exist anyway, so this can't happen. But this is not where we come up with the ideas and notions of best practice. This is maybe a more realistic assessment of where we learn about best practices. The folks on the bottom of the screen are investigating best practice, thinking about anti-patterns, and they're working. If you've ever met any of these individuals, they spend a lot of time outside of these events working with customers to try to remove anti-patterns from environments so that we don't have those issues. That happened without my control. That was an example of a loss of control. So we're going to talk about 4 anti-patterns today. These are anti-patterns that we see in a lot of partner accounts. These are anti-patterns that we see in customers' accounts. And importantly, these are anti-patterns that lead to real outages for real customers. And in some cases, these examples are taken from my own experience or Alan's experience as well. So the first anti-pattern we'll talk about is the loss of control. And what we mean is the loss of control of an AWS account. That's the domain that we're talking about. Here's a simple example of an AWS infrastructure. I just culled this from our reference architecture website. It's really easy to create these infrastructures by operating the AWS API. I can define this infrastructure as code. This is a pretty typical view of an AWS service or an application hosted on AWS. It's really well designed. So this has got private networking. This has got network isolation. This has got fault tolerance built in. And by operating the AWS API, I can easily create multiple well-architected individual instances of applications. I can build a business around offering a practice like this. So this is an example of the same application delivered over and over again, maybe for multiple customers. It could also be different applications in a typical production environment. Again, the essential point is this is a well-architected application. Within the application scope, there's really nothing to say about it. It's designed to best practice. How do we actually build these infrastructures on AWS? We operate the AWS API. We can operate the AWS API from anywhere in the world, and we're authenticated with a service called IAM. Anybody with a long-term security credential for your account, ideally your administrators. I'm seriously losing control here. It's great. Preview. Anyone with access to a long-term security credential in your account, we often create these on purpose for humans to administer this environment. By default, they can actually administer the environment from anywhere in the world as long as they've got a security credential. We give these out to people, administrators. We often see folks creating long-term security credentials with overly broad or very broad permission sets, admin accounts, if you will. We see use of the AWS root account credentials. used in this way. So we generate credentials for the root account. This is unrestricted access to the AWS account. We often create, as we start to introduce a little bit more best practice or we introduce automation to the account, we often create temporary security credentials as well, often with very similar permission sets. So admin, it's, hey, I'm going to make this credential. I can create the credential. It'll last for 5 minutes. It'll last for an hour. However long I need my actual automation to run, the runtime for that, it'll use the security credential to perform that task. And this starts to give me a little bit of protection. You know, at least the security doesn't hang around forever. What's the issue? Long-term security credentials can end up leaving our control. They stick around forever. They're given to humans. It's just a bunch of bits. They can end up on mobile devices. They can end up on thumb drives. They can end up checked into public repositories. We put them in temp files. We accidentally check all that stuff in. Alan wants me to mention GitHub. I didn't want to mention anybody by name, but that's where these things can end up. And if this is a public repository, somebody can read my credentials out, potentially use them.
And I think, you know, one of the things that's worth pointing out here is with these, you know, many long-term credentials, you tend to forget what you've got. And, you know, you go into IAM and you're doing an audit and you're like, I don't know what this does, but I'm kind of too scared to push the delete button on it because, you know, what if that breaks everything? And that creates a barrier to audit and refresh and actually keep in control of these things.
Right. And it's extremely natural, and this is kind of a reoccurring theme with the anti-patterns. It's natural as we approach the platform for the first time to investigate the platform and the console with a credential like this. Generate those credentials, operate the API, play around with the CLI, start to explore automation, and they end up sticking around and becoming persistent. Temporary security credentials, although we may intend for them to be used by automation, can be intercepted by a user. So if we have a build box, we generate some temporary credentials, those credentials get dropped into a temp file. If anybody else has access to that box or in some way gains access to that box, again, preview. I'm going to quit touching that button. An individual can grab those credentials. They're not automation, they're a person, but they can still use them in the same way. Whatever those credentials are authorized to do, a person can use them as well, unless we're careful to constrain access. So what can happen if an attacker gains access to credentials, either the temp tokens, the long-term security credentials? They can operate our API just like our automation can, just like our administrators can. And this is kind of a unique scenario. I'm not aware of a data center environment, I spent a lot of time in data centers, where the loss of a single token would simultaneously grant access to operate my applications, drop my infrastructure, remove my security policies. It's essentially the key to the data center, the key to my backup vaults, all of this scoped into a single credential, all of this in a single administrative domain. So that's a bad day, no problem. I mentioned that this application is actually well architected. I'm making backups. I'm dropping those backups into S3. I've got full audit artifacts. I've got CloudTrail enabled in my account. I know exactly how the API was operated. So potentially I at least understand the scope of the vulnerability or the scope of the event. Luckily, these are all authenticated with IAM and potentially exactly the same security tokens. And so those same attackers, after they're done dropping my production application, they also remove my backups, or if they're nice, they just encrypt my backups and offer to decrypt them. They also remove my audit logs, and then I've lost everything. I've lost my ability to continue as a going concern. So this can happen. So in this talk, we're going to talk about anti-patterns. That's the anti-pattern, loss of control. We're going to talk about simple ways to mitigate, ideally simple, at least conceptually simple. As Alan mentioned, it's difficult to go unpack your production operation. You've been operating production for years. We really want to drive best practice in IAM into that production operation. That can take a while. But there's a simple thing that we can do. It probably would take about the scope of an afternoon for an AWS to set this up, an AWS expert to set this up. But we can create another AWS account. Credentials are scoped to an account. That's the administrative domain. Don't put all of your eggs in one basket. Don't put your backups and production operations in a single AWS account. Set up another AWS account with a much more restricted credential set. This is extremely easy to reason about. Nobody can delete anything in this account, right? I can have an account, a policy associated with that credential that says that account A can write things to this account, but account A cannot delete anything from this account. Maybe I don't create a credential that allows anybody to delete anything from this account. Create immutable audit artifacts, set up automation within the account that's authorized to remove backups, but I don't have a human that's able to do that. If anybody creates a token like that, that's a violation. So it's a bad day. My credentials are exposed. Account A goes away. I use credentials for B, grab my backup artifacts, and recover into a new account C. So this was a bad day, but ultimately we've been able to recover from this event and continue as a going concern. Again, this is a cost-neutral exercise. It's maybe a half a day of administrative effort. I don't need to change anything in account A to make this work. I'm going to choose a different bucket that I just set up and authenticated to flow my backups into. Over time, you don't have to read this. This is mostly for you guys to take a picture of it if you want to. I see some people taking the opportunity. Over time, we can start to develop more extensive best practices. We can audit our accounts. We can understand how it's being used. We're definitely going to lock away our AWS root account. There's nothing we can do to restrict that account. It's the main reason why we want to discontinue use. I can't create a policy that controls how the root account is used. If somebody uses those credentials, they're going to do whatever they need to do. I'm going to create individual IAM users. I'm going to enable MFA for privileged users. If I lose control of the credential, at least I've got an MFA enabled. I'm going to never automate with privileged credentials. It's automation. I know exactly what it's going to do. I'm going to define the policy set that matches exactly what that automation is attempting to do. I'm going to enable rotation. I don't have the issue of a credential lasting for years. I can interrogate the IAM API, understand exactly when credentials were used, how old they are, and establish programmatic rotation of those credentials. Audit for compliance always. But the main point here, if we learn nothing else from this talk, I'd like you to consider establishing separate administrative domains, a separate AWS account for the purposes of backup and audit at least, and we can extend that model into dev, test, QA, and other uses. The second anti-pattern that we want to talk to you today is gaps in control. So here's another view of an AWS, a very simplified AWS infrastructure. The things on the left-hand side of the screen are ways to operate the AWS API. We've got a management console for interactive access. We've got tools like AWS CloudFormation for building environments programmatically, defining our infrastructure as code. We've got a variety of AWS SDKs for integration into your own tooling or into partner tooling. Of course, we've got the AWS CLI. We're going to use that, operate the AWS account. We're going to operate the API. And on the back end, we can develop our controls and our compliance automation using services like AWS CloudTrail. CloudTrail is a free service. You turn it on. It'll give you an audit artifact every single API call, exactly who did something in your account, when, and from where. AWS config gives us a point-in-time inventory of our account. Examples here. So what we've got here is an example of a CloudTrail log. This is just the top bit. This is what we get with this. We get the username. We get the account ID. We get the service used. We get the region it occurred in. We get the source IP address, where this call was made from, which IP address. We have more data in the body. Config is awesome as well. This gives me a point-in-time inventory. It's a snapshot of my inventory in AWS. Again, I've operated data centers for some number of years. Some people would even say decades. I don't like to think about it too much. An inventory in a data center is an exercise that spans weeks. And it gives me a mostly accurate view of what's running in that data center.
Except for those 3,500 servers you didn't find.
Yeah. I either find extra servers, which is always even more disconcerting than not finding all of them. Like, where did these extra servers come from? I find 99% of my tapes, which is pretty good unless I want to do a recovery. In AWS, config gives me a point-in-time snapshot. I can make continual snapshots, and I can build compliance frameworks using these two tools. And that's what folks in AWS should be doing and frequently do. So here's an example of the compliance automation that we can start to build into our environment. This is an example security group policy. This is essentially a firewall policy. It's pretty good looking. I've got a protocol specified TCP. I've got an input, the source IP defined. The ports are port 22. This is SSH. That looks pretty good, except for that number. So instead of restricting this access from one host, I restrict access to about 5% of the internet, so it's pretty close. So as long as we trust 5% of the internet, this was a good rule. The nice thing, though, is this rule will appear in both config and CloudTrail after it's been enforced. And so I can write some simple compliance automation to look for rules like this. I can look for /0s. /0 is probably a violation of my security policy, and I can detect that and alert on it, and folks often do. This is something that's really hard to see with your eyes, but it's pretty easy to see with compliance automation. Here's an example of a security policy that somebody in this room wrote in order to deliberately avoid his own detection rules at 3 o'clock in the morning because this person, the anonymous person, really wanted to use RDP. And he knew his own compliance automation was going to kick in and not allow him to use RDP. So he wrote a rule that would avoid his own compliance checks. This has got a well-formed IP address with the proper /32. That's the right number there. But instead of calling out an IP protocol, which would be too obvious, I'll just pick any. And instead of calling out the RDP port, I'm going to use 3388 and 3390, neither of which appear in my detection logic, so we're all good. As long as I remember to revert this in the morning, which I didn't, as long as I remember to revert this in the morning, we're good to go. So this is an example of a configuration that's actually hard to spot with automation. I wrote the automation, so I know what it's going to say, and I know how to avoid it. Other folks can see the same stuff. But it's pretty easy to spot visually. If I had another person looking at this, they'd say, Mike, why did you write this rule? Tell me the truth. And I would say, because I really needed to log into that box. So that's what's wrong with that picture. So let's drop over into S3. S3 is another thing that it's hard to automate the checks for compliance. And I think Alan has a few comments on this.
Yeah, no, I think this is an area where if you follow any news about the cloud for the last sort of 6 months, what you would have is the template of the news article that says, company X has leaked N terabytes in a public S3 bucket. And these are some of the simplest control gaps where we go, I have an S3 bucket, I have a policy on it, but that one time I just needed to get access to it from an account where I didn't want to set the bucket policy because IAM is super hard and the bucket policy was super hard and I couldn't be bothered to figure it out. I just made it public and then kind of finished what I was doing and moved on with my life. And this is a very common control gap. And again, this is one of those ones where you'd say that automation would solve it, but in a lot of cases, that's not enough. Again, you also need, in a lot of cases, humans to take a look what's going on with things like buckets where there's ambiguity about was this meant to be public, was this not meant to be public? And having both an automation that says something weird happened here and a person asking, why did you do this weird thing?
Right. And a similar situation exists for other AWS objects. We can define pretty tight security groups for things like EC2, but I can add an ENI that's in a public that's associated with the public network, gain access temporarily. So lots of complex rules and lots of complex features in AWS that enable lots of complex authorization process. And kind of the point is, we need a human to decide if this should be public or not. We should probably use tagging. But also we need automation to look at more than a single artifact. A single change in the API is not going to be sufficient to tell me if S3 is public or not, right? This is a whole flow chart. This is a simplified view of the policy. So if I've got checking looking at individual events, that may be insufficient to tell me if this is open or closed. So let's take another view at our initial setup here. And this time we're going to try to identify some gaps in our automation that we might have become a little bit overconfident with. The first thing to note, and it's really important, is the things on the right-hand side of this screen happen after changes have been made to the environment. These are essentially post-facto controls automation. So I can open the environment, I can make an S3 bucket public, and CloudTrail will tell me about this if I'm parsing the logic correctly. Config will tell me about this. But in the intermediate period, it's actually open and vulnerable. And so if somebody's trying to do something expediently, they're trying to open up access to a bucket, they can grab the data out of it, and then our automation will clamp down later. So it's retrospective. So what can we do to start closing these gaps? The first thing that I would consider and recommend, and this is a highlight of this talk, is take advantage of the experience AWS has in operating this environment on behalf of a large number of customers and a large number of partners. And that is, augment AWS config with AWS managed rules, which we've written that are informed by the experience of helping folks eliminate anti-patterns from their environments. So this is a feature called managed rules for config, and it has rules for things like checking if an S3 bucket is public. So take advantage of the S3 knowledge, or the S3 knowledge that our support engineers have, that the S3 team has, that the solutions architects have, and that we've embedded in these managed rules. We'll keep them up to date as the service changes, kind of another issue. Also consider eventing to a service like SQS and eventing Lambda for custom logic to revert changes. So we can use Lambda to investigate a change. If we decide it's not compliant, we can use Lambda to revert that change immediately. So that'll close our window of vulnerability. As opposed to alerting somebody that something's amiss, we can use Lambda to make that change and put it back. We can also use a service like Amazon Macie. Amazon Macie is going to look inside of your S3 bucket, look at the objects therein, and use machine learning to try to figure out what kind of data might exist there. So I've operated environments that had petabytes of storage in S3, and over a long period of time, we started to accumulate data, and it became very difficult to understand what exactly was there. Aside from the problem if it's public or not, what does the data actually represent? Amazon Macie helps you understand that, and it also helps you understand how it's being accessed and if that's compliant with your stack. So this is another way to kind of use AWS expertise to help me operate the environment in a safe way. This is really boring, but you should really consider change control. Change control has been around forever. It's probably not news. Some folks get really excited when they come to AWS and may think you don't have to do it. But this is the only way to make sure changes don't go into production, right? So the stuff on the right-hand side, as cool as it is, happens afterwards. There's a gap of 10 to 15 minutes in some cases before we detect the change, and then there'll be another gap before we decide to do something about it. Change control, another pair of eyeballs looking at these changes is essential. It's an essential component of your infrastructure. How can we do that? We can do that in a lot of different ways. We'll talk about in the next section using AWS CloudFormation to automate my stack. I can run AWS CloudFormation and find out what sorts of changes are going to be made, and then have another approver decide if that's an OK thing to check into production. We can also absolutely automate the controls over here. Change control no longer needs to be an entirely manual process. All of this stuff is described with code. Check that code in. Check it on the front end using very similar logic that you would check it on the back end. Intercept those changes on the front end as well. While we're at it, I don't know if you missed it. Maybe don't use that AWS Management Console to manage in production operation. It's another anti-pattern that we see very frequently, and we'll talk about it in the next section a little bit. The AWS Management Console is a great tool for discovery. Using the AWS Management Credential with an admin credential, using the Management Console with an admin credential is a fantastic way to learn about AWS. It's also a fantastic way to break all your automation and make sure nothing works. So consider discontinuing the use of manual automation, especially, or manual control of the AWS environment using the console or using the CLI. It's a little bit more defensible for a significant operation. And actually, I'm fairly adamantly opposed to using the console even for read-only access. with one exception that we'll talk about at the very end. So consider removing that. Hand this over to Alan to talk about the utility of auditors.
Yes. We made the point a lot here that automation is great, but when you automate, you're automating things that you know about. And the one truth in the universe, well, the three, taxes, death, and the third one is that you only know what you know and you don't know what you don't know. Automation and understanding what you need to automate, what's the next thing you've got to fix, is key to knowing, I've got a gap, I've closed that gap. What is the next gap? And there will always be a next gap. It doesn't matter what environment you run in. It doesn't matter where you run your servers, whether it's in the cloud, whether it's in a data center. It's irrelevant. There will always be a next gap. And having a continual process of audits, understanding what changed, what didn't change, why it changed, is key to identifying that next gap.
Security operations is also essential. It's important to understand that we don't actually mean individual name people that have the function of auditor in your environment. We mean that an individual has the task of audit. So this is a repeatable, reoccurring thing. We need to continually audit our environment. We need to have folks that are responsible for security operations in AWS. Doesn't mean that that's their only job, but at least we have some named individuals performing that function in our environment. And then finally, partner applications. So we can be really confident that we've got proper change control, proper automation, we're auditing everything, but we're going to verify that the artifacts that we have in place are actually doing what we think. I'll go back to that.
Loss of control.
Seriously, incomplete automation. Partner applications can be configured to probe our buckets, probe our assets. They can be configured to download the list of external IP addresses that exist in our account, and then test them to make sure that our security rules are actually being enforced. Some partner examples would be like Dome9, Cloud Health, Turbot, folks like that. So active penetration testing. Partner applications can also reach into our account and augment. If I want to get started with CloudTrail, I like the idea of using CloudTrail to build a compliance automation stack. Partner applications can help me get started with that as well. So here's the slide to take a picture of. So the anti-pattern is a reliance on incomplete controls automation. Best practices that we want to go to, pretty simple to start to use managed rules right away. We'll talk about canary events in a bit, but we also want to use external tests and tools for validation. Trust but verify. Make sure that we know what we're doing. Audit to verify compliance. Audit is an essential component and remains an essential component in AWS. See a little underinvestment there. We want to add manual checkpoints prior to pushing changes. Again, it doesn't do us a lot of good to have a super fancy controls automation stack. If I'm pushing changes in, there's a 10 to 15 minute lag, and there's a gap for folks to hop in there. So automate everything but mind the gaps. Next section is on automating outages, the third anti-pattern that we can speak to today. So as we've discussed, we can easily automate our entire deployment using CloudFormation, similar tooling, HashiCorp Terraform, Puppet, Ansible, Chef, Salt. Can keep going. But we can define our infrastructure as code, and folks often do. As folks approach the platform, the usual transition is console automation and CLI automation, then maybe reaching for a tool like CloudFormation or Terraform to start building automation. This is a very simple environment, again, with simplified diagrams just to kind of illustrate the point. So we can scale in or scale out automatically using autoscaling groups, or AWS native services like Cloud Lambda and CloudFront that give us that elasticity in our environment. So here we've got a simple environment, Route 53 for name resolution. That's going to point to a load balancer, an active load balancer. We've got some EC2 instances registered with the load balancer to handle load. Only one in this case. We've got a nice simple environment. We've got an RDS master database server. It's the mcan on the bottom. And on the right-hand side, we've got some static content distribution with CloudFront and pointing at resources in an Amazon S3 bucket. So pretty straightforward. Okay, just making sure. So we can start to contemplate using automation. We can start to contemplate blue-green deployments. This is a solid practice. This is the idea that I'm going to stand up a new web application server, test it to make sure it's working properly, then introduce that to the load balancer, and remove the original instance, right? So this is a great way to push new code into production. I've got a brand new artifact, test it, make sure it works before flipping traffic over to it. However, if everything's in the same CloudFormation template that the original green box is, what can happen is we accidentally drop our database server at the same time we get rid of our web server. It's typically not a great idea, it's typically not intentional to get rid of our stateless and stateful infrastructure at the same time. Similarly, we can use AWS autoscaling groups to scale out our web infrastructure. We can scale in, we can scale out, we can test that, we can make sure it works fine on a Wednesday afternoon when the sun is shining. We go home for the weekend, come in on Monday morning. We had scaled in over the weekend, we don't have as much load. We come in Monday morning, we don't have those boxes. We failed to scale out. Some change happened, something in our environment changed such that it made it impossible to scale out. So two different ways that we can end up with automated outages. I don't have enough servers here to handle the load. This is an outage from the customer's perspective. Here's kind of everything in one slide. We've got a blue deployment. We may have static or hard-coded addresses. We've got a mix of manually operated and automation in our environment we're intending to do blue, we're intending to do green. We end up with something more like gray. We're not quite sure which production application is using which database. We can end up with multiple databases in our environment. I'm sure nobody in this room has this problem, but with AWS, it's easy to build applications. It's easy to build software. It's easy to copy data around, and it's easy to get everything a little bit out of step, and it can be difficult to operate in that case. So blue, green, gray. So what can we do about this? Pretty simple steps. As we're approaching automation, we need to start using automation. We need to start using tools like CloudFormation. Got a lot of services that start with the word cloud. What should we do? We should decouple the infrastructure into stacks based on the responsibility, the function of that piece of the application, and any requirements around persistence. So what does that look like in practice? With CloudFormation, I can make stacks, individually defined stacks, and use different stacks for different parts of my application, and then manage them independently. I can still link these together into a logical application. These stacks are called nested in the idiom of CloudFormation. Our partner tooling uses different phrases to describe this exact same concept. But what I've done is I've decoupled web server administration of the infrastructure. Web servers like to scale in and scale out a lot. I like to replace the code there. I like to do blue-green deployments. I don't often have to do that same type of work with my database here. So what we see is folks building a CloudFormation template with everything in it, running that CloudFormation template for a year or longer, and then somebody comes along and naively drops the stack, right? So I lose everything in that case. And so in this model, we're going to carve out functional components, and especially the stateful components, into separate administrative domains. So it's this concept of administrative domain, but here we mean application function. So here's a way that we can use CloudFormation. Here's how CloudFormation works in this model. I've carved out everything into individual stacks. My web administrator or the infrastructure, the DevOps person in charge of my web tier is going to edit a template. They save it. They run AWS CloudFormation to develop a change set based on the change I just made. I view the change set, and this is where we have an idea, maybe another person is going to view the change set. Not the person that made the change, but another person is going to validate that that's a good change to make in the production environment. And critically, that my web application update doesn't say anything about a database, right? There shouldn't be any need. Maybe an object pointing to the database, but we're not going to replace the database as part of this function. And then when we're all ready, we're comfortable with the changes that are made, and lots of partner tooling has exactly the same type of concept of like a pre-flight check. What sort of things will happen? Then we go ahead and execute the change. And I use this icon directly out of our manual, mainly because I like the idea that CloudFormation is a little crane doing things. But the CloudFormation then gets to work and updates the stack and updates the state machine that describes our application on our behalf. So here's our friend, the AWS Management Console. The AWS Management Console lives in a universe of managed services intended to help me automate my production environment. If I use these at the same time, if I use the Management Console at the same time that I use CloudFormation in the same account, I can end up with problems. Best case, maybe CloudFormation just doesn't work. Worst case, I scope in database assets, persistent stateful assets, into the CloudFormation scope, and I start automating outages. So the answer pattern is incomplete automation and testing, decouple stateful and stateless infrastructure, management automation. Don't automate these with the same exact, we can use the same tool, but we're not going to use the same configuration for stateless and stateful infrastructure. We want to limit, and I can't emphasize this enough, limit interactive access to infrastructure. We don't want Mike logging in at 3 o'clock in the morning to make a change that he then forgets to undo. If nothing else, this is going to mess up our compliance infrastructure. How can we get to that? We're going to define and enforce a tagging policy. Most assets in AWS can be tagged. They can be tagged with a tag like version number of the application, and we can check that version number in our CloudTrail artifacts, map that to our CMDB, and make sure that this was a change that is associated with a valid version of my app. Ideally, that's going to help us catch folks making changes outside of our automation. Implement blue-green and rolling updates. Put new infrastructure online, check that it's healthy before you put traffic on it. That's all that means. Rolling updates is kind of another method to get there. Test infrastructure and automation in non-production environments. This, again, is that conversation around administrative domains. If I define my entire environment with CloudFormation, I can make another environment with CloudFormation, make sure that all these changes are doing exactly what I want before I go ahead and roll that into production. I won't say the word administrative domain ever again. If you guys are OK with that. I think we get the point. Alan, we'll hand it over to you. Oh, you want to operate the, be careful.
So, is it hairy?
It's a little touchy.
OK, so those of you in the room who work for an MSP or were involved with your MSP's audit to the AWS Managed Services Program would have seen a control as part of that that says you don't have backups unless they're tested. And the reason that comes about is because I once experienced Schrodinger's backup. It's a bit of physics background if you're not aware what Schrodinger references. Erwin Schrodinger in 1935 said that he came up with a super elegant thought experiment that had something to do with quantum mechanics. You don't care. The point is there was a cat in a box, and if a random thing happened, the cat was either dead or alive, and unless you opened the box, you couldn't tell. So unless you measured what happened, you couldn't tell. So how does this apply to the world we're in? Well, I've got this infrastructure, this relatively simple application. It's an EC2 instance. It has a bunch of EBS volumes on it that I keep my database on, or I have some persistent storage on that I need to keep backed up because that's my business, is the data. Or I have a database and I'm using EBS snapshots to back it up. I turn it on or off before I do the backup, or I don't, because how often does that automation actually work? RC.D scripts are great unless they never work. And, then I do a bunch of snapshots using the laser, and I create a bunch of snapshots over time, or I'm using the native tools and pushing that stuff directly into S3, and I'm done, right? I'm making backups. I can look my CTO in the face and go, listen, we've got backups. We're all good. But the problem that we run into is the Schrodinger's backup. We have a random event that may or may not fire at any point in time. The ultimate definition of an outage or a disaster is that it may or may not ever strike you, and it may or may not ever trigger some kind of a recovery. And after we're done recovering, we may or may not have a living application. Why is that? Well, My most personal recent example is restored a tar GZ from S3 because I was using MySQL backup and pulled it onto the box, and man, that copy was quick. And I hadn't done ls minus l, I just did a normal ls, it was there, and I tar unzipped, did the whole tar unzip thing, and man, that was super quick. And there was just still tons of storage on this, like this is going way too well. Until I looked into some details and realized that a 0 kilobyte backup is just an inode, and my database is not just an inode, thus useless. And then I went to my S3 bucket, and there were tons of files in there. And I hadn't been billed for any of them in like 3 months because they were all 0. And what we do when we back up an environment, we have a jump box, and that jump box manages the security domains between my account that I push the stuff into another account, and it has a disk on it. And I copy the backup onto the disk, and then I tar it up, and then I push it. Except that one day where I was messing around with security groups and broke its ability to access S3, and the disk filled up, and I never alerted on it. Now, this is all a lesson in my own stupidity. That's not what I want you to take away from this. Schrodinger's backup is not about doing silly things that break backups, because anybody who's managed a massive tape library can tell you it never, ever works. We know this. We're prepared for this. The 99% of the tapes that we found will always be there. The problem that comes in is when we don't ever test them. So the mantra that I have and that I instill in every partner and customer that I talk to is, a backup is just data until you test it. You do not have backups unless you're doing some kind of testing. Now, testing doesn't mean restoring a massively complicated environment every time you run a backup. I've managed billion-row tables in databases. You can't just restore that. It's not practical. But what you can do is go, I'm backing up files. Are they getting bigger every day? No backup in the history of anything useful has ever gotten smaller. And if it is, you're doing it wrong. So are my backups getting bigger every day? Am I saving zero-size files? Are the number of EBS volumes and EBS snapshots going up? And am I trimming the oldest ones, and am I actually deleting them? Using tools like CloudTrail to identify these things and go, okay, I know I'm deleting files from 2 weeks ago. That automation didn't break. I have things to delete. I didn't run the delete and 0 things happened. Testing and ensuring that your database exists, or that you're at least, I talked a lot about databases, but let's be honest, that's where this happens. This does not happen on unimportant files. Never. You can always find your mail from 2 years ago. That critical database, never. So it's really important to think back to what makes sense around a backup. More than just going, okay, I have a restore process and we test that in application. That takes time, and that takes discipline, and that takes a lot of operational excellence to do. Today, you could go and write some super simple Lambda code that checks the size of your backups and tells you when yesterday is bigger than today, or the same size and that size is 0. So, the anti-pattern. Schrodinger's backup, untested, unvalidated backups with even the simplest validation. The best way to manage this is automate your backups, but monitor the automation continually and at depth. It means ensuring that you're doing sensible things and you're checking the most sensible things about it. And very often, you want to use the most native tools for a problem. EBS snapshots are phenomenally good for backing up most things, except live and hot databases. Don't do it. It doesn't work. You can't snapshot a live and hot database. It will be inconsistent. If you've worked with databases, you know this to be true. I promise you it is. Use the native tools and monitor how those native tools are working. The last point I'll make is, as you walk out of this room, somebody will turn to someone else and go, we don't need to worry about the backup thing. We replicate. And I'll tell you what the problem with replication is. It's when Alan's writing a script to update the password of some users in an LDAP directory on a global infrastructure. He needed to, he was asked that some users in a specific place needed all their passwords reset. Cool, so he wrote a script that interfaced with the LDAP directory and updated it, except he forgot the where clause. And that kind of sucks, because you wouldn't believe how quickly that change replicated to every copy of the LDAP directory and ruined everything. And we didn't have good backups.
I'd actually suggest that having everybody's password be password would be a relief for our IT operation and help us for at least a little while.
Yeah. Listen, the computer's logged in perfectly.
Yeah. So how do we establish best practice in our environment? We've gone through 4, let's call them classic anti-patterns. And we talked about best practices that we could use to solve those particular use cases. There are more anti-patterns that exist in the wild. These are the ones that I see most frequently. I've worked with about 150 AWS partners in the last year, either directly or indirectly, investigating infrastructures, and these are the ones that bubble up most often as findings. So how can we get the best practice in our environment? I think we need to understand that it's a journey. We need to identify the best practices. We want to learn from mistakes, and we ideally want to learn from the mistakes of other people, like Alan.
I'm a basket case for learning.
Yeah, we want to use FAQs that people like Alan write, in a bad mood in the middle of the night. We want to use troubleshooting guides. We want to use backend recovery steps. We want to think about these things before we deploy. It's often much more difficult to fix things after we put it into production. We want to continually test our assumptions. We want to do things like trial recoveries. We want to do things like DR exercises. We don't need to get obsessive about automation for these things. We can do them manually, and they can be very revealing. We can do wargaming. This is something that I talk with partners and customers a lot about. We can absolutely fully automate our entire recovery stack. Lots of people are there. But it's often very, very instructional to sit down at a round table with our ops staff, maybe with our chief of security, and just toss out a scenario. What would happen if we lost control of our root credentials in our primary account? And then we'll see, maybe the room gets a little quiet. We start to think through things. Somebody goes, maybe that. And then maybe somebody goes white. Maybe somebody runs out of the room. These are the best kind of wargaming scenarios when somebody goes and realizes something they should do immediately. But we can test our assumptions, and we can wargame. We don't need to get to the automation right away, and we can even do this iteratively. We can do wargame every quarter, where we sit and have a scenario that we walk through. We do a paper exercise, very instructional. But we're going to reassess frequently. The biggest takeaway is AWS changes. We enhance the service. We had 1,000 feature or major service releases in 2016. I don't know what the number is in 2017. And oftentimes, we're delivering services designed to help you with these problematic use cases, with these anti-patterns. You can schedule periodic architecture reviews with AWS Solutions Architects. So AWS architects are incented and trained to help you identify these anti-patterns and to help you identify best practices that we can use, prioritize based on risk, or prioritize based on cost, or ideally both, and ideally give you pass-through remediation that may be cost neutral, maybe save you a bunch of costs in the environment, may be relatively easy to deploy, but could save you from having a bad day. So use those facilities. We have a service called Trusted Advisor, so use AWS services. Trusted Advisor is available on the console, and I will admit it's a useful console service. So maybe authenticate yourself to use AWS Trusted Advisor and nothing else on the console. Log in and take a look at it. AWS Trusted Advisor performs automation and machine learning in your account looking for anti-patterns. It's looking for a lot of the stuff that we discussed today. It's looking for opportunities for fault tolerance. It's going to identify risks in terms of security. It also talks about things that we didn't get to today. We don't have time to get through ways to optimize for performance and add anti-patterns that deny us the availability of performance, like taking advantage of new instance types. It's also going to make recommendations around cost optimization. So again, these are AWS best practices that we learn from helping customers have success on the platform. We embed those, we code those up, and we drive them into Trusted Advisor, and we expose that on the console. It's also available via an API, which is how I recommend you use Trusted Advisor. Use partner solutions designed for security and compliance. So if what I talked today about CloudTrail and config was a little new to you, we've got partners that are expert in these areas. I mentioned some of them earlier. Partners can help you look at your CloudTrail. Partners can help you look at config, make sense of those, and define compliance policies around them. Partners can do external penetration testing to validate our assumptions about the environment. We can keep that up to date. Partners have a vast array of services designed to help you operate your AWS environment securely and efficiently. Take advantage of those. And then finally, I want to introduce, I think this is pretty well known, but I really want to talk about AWS Well Architected. This is a collection of best practices that we publish in a series of 5 white papers where we investigate your operation, both kind of the detailed runtime operation of your AWS environment, things like you're not using, are you using the root account, as well as do you have a relationship with the support entity at AWS, so kind of more operational things. 56 questions embedded in that white paper. Take a look at them, read them. There's a lot of best practices that we recommend. And then we go into detail in kind of some of the supporting white papers. AWS solutions architects are trained and incented to perform well-architected reviews with you. We want to engage with you. We'll walk you through these 56 questions, and we'll help you build a prioritized list of things to fix in your environment. This is something we desperately want to do. Please reach out through your partner developer manager or your account rep, and we'd love to perform this exercise with you. And with that, thank you. That's our presentation today. We will be at the